welcome everyone to this Proving Ecosystem community call. This is our fourth or fifth call, I think, from memory, and we've got just under 2 weeks until the contest kicks off. So yeah, we're super excited to see progress. ProverNet is live for testing, and we'd love to kind of dive into your questions, do a quick pulse check, and then there's going to be a demo as well from the engineering team to kind of walk you through some of the flows. We've also got lots of time at the end for Q&A, and we've got lots of Aztec engineers on the call, so please get technical. All right, should we start with the pulse check? Steve, do you want to try and do these polls?
Cool. Let's try this bit of interaction. Has that appeared on everyone's screen?
Awesome, yeah. Yeah, we're just trying to get a sense of kind of how people are finding the initial kind of integrations, and yeah, trying to get a sense of kind of general readiness for the contest. We know the timelines are a bit tight, but we have kind of resources available to help people if needed.
And also, aside from the numbers themselves, I'm curious if anyone running the local ProverNet network has run into any issues or anything we can help with.
Would we like to talk about the first question, or shall I suggest the second question?
Feel free to take it, Steve. Okay, and like while the poll is running, aside from any issues that you may have run into, I'm curious if there is anyone that started work on a custom integration to know more about how they are approaching it, or if we can help in any way on discussing the design, or most importantly, knowing where they're integrating and like which part of the stack they are hooking into.
Maybe we can pause for a couple of minutes here and just spend some time if people want to dive in on any kind of pulse check problems or challenges that have come up. We'll have longer for questions at the end, but before we dive into a full demo, if people have burning questions or kind of problems or challenges, please unmute yourself, raise your hand, and we'll try and collate them so we can answer them.
We're about 50-50 across the board, actually, for all three of the questions.
Okay, that's good.
The fourth being obviously more qualitative, perhaps, so worthy of discussion.
Hi, this is Robert. I haven't tried to connect to ProverNet Network, and I'm wondering, I have it running. I'm not sure whether I should call it locally, but I converted your Docker stuff to Kubernetes manifests and running it in Kubernetes. And I'm wondering, is there any documentation which would show me how to connect to ProverNet Network, what changes are required?
Sure. Yeah. On the Prover integration guide, there is a section on how to connect to ProverNet. Basically, what environment variables you have to change to instruct your Prover node to connect to the remote network we're running. The only thing missing there is an APA key that Phil has shared on Telegram group, which we want to keep private because it's what's currently gatekeeping access to the network, ensure that only participants of this integration program are able to access it, at least for now. Thank you very much, Jim.
Thank you for the link. Yeah, that's very helpful.
And like aside from the environment variables, the main change is that you don't need to run everything, right? Like we're running on our end the main Aztec node with a sequencer. We're running the L1 fork. And the only thing that you need to worry about are the prover node and one or more prover agents.
Okay. That's great information. Thank you.
Sure.
Hey guys, can you hear me?
Loud and clear.
Hey, just a quick one. I've just connected to the ProverNet in the last 20 minutes or so. So I haven't really had a chance to look at the what's being wrapped. I know it's Docker running containers in the background from the sandbox. In terms of instrumentation, so I did notice Grafana in some of the definitions in the compose files in the repo. Is that in the sandbox as well, or is there like an endpoint I can connect to and connect to another, my own Grafana or something like that? Anything interesting I could be looking at right now?
Yeah, I think there is a set of environment variables that you can tweak for sending OpenTelemetry metrics that then you can pick up on Grafana. Phil, I think you have this part more clear than I do.
Yeah, so Santiago's right, and you can define a couple of environment variables that will allow metrics to get pushed to as an OpenTelemetry collector. So if you're familiar with OpenTelemetry, OpenTelemetry requires a collector. And then you would also have to run a Prometheus instance that would scrape the collector, and then a Grafana instance that would use the Prometheus data source. And obviously you could then put a dashboard on Grafana. That's essentially the setup that we run. So we monitor, the ProverNet, the main network. So that is available. You could set that up. It's not something that's immediately available out of the box. You would have to do some work, but it is possible.
That's perfect. We're running an OTel node, so we can just hook up to that, I think. Thanks very much, Phil.
Okay.
Cool. And also, I believe we have a Docker Compose template on the open source repo showing how to set up the collector, Prometheus, Grafana, and the like. So we can send a link to that after the call. I'm not sure who's next on the queue.
Constantine, do you want to go?
Yes, hi. So I understand about Grafana, but can you provide some dashboard from yourself where we can see some metrics from other provers? For example, we want to make our prover fast or something, but we need to compare with everyone and try to run your prover on several types of hardware, just to understand how it will affect proving time and so on, and where we in this leaderboard. Not only our metrics, but metrics from your side with our competitors.
I think we can share the metrics that we are seeing on our own prover nodes and agents that we are running as Aztec. I mean, we also run proving infrastructure to make sure that everything is working fine, so we can share that as a baseline. For sure, we can also share some sort of leaderboard showing what are, how many blocks every prover has managed to complete, which is going to be the main metric that we will be following during the week of the contest, right? We want to focus more on reliability and the number of blocks proven as opposed to just speed. As long as you manage to prove everything within a time window, you should be good, and speed should only be a concern in terms of the tiebreak. As for sharing internal metrics of other provers, I'm not sure that's on the table. I'm not sure if every prover would be comfortable with that.
And one more question related to options and variables. You said that you have plenty of options, and do you have complete list? For example, if I want to have my logs in JSON format or something like this, I observed your repository and there are plenty of information, but do you have some aggregating information about options for your prover?
Yeah, if you the way for running in terms of options, the way for running a prover, actually the way for running any component of the Aztec network is via the CLI that's exposed on the Docker image that we ship. You just if you run Aztec help, you will get a detail of all the options that you can use, and you can fine tune for every component. Still, the options that are relevant for you should be listed on the integration guide that we shared. But if you want to go a bit deeper, for sure you can check that. As for logging in JSON format, there is a PR going to be merged soon, so we can probably make a new release of the ProverNet image that includes that. So you can have your logs in JSON format just by adding a new environment variable, which we will add to the documentation.
Okay, thank you. And am I right that you are suggesting to run Prover on a cloud? I saw this type of M5 8X or something like this.
Yeah, like where that M5 spec is just us sharing what we're using right now for sharing the prover. There is no need for you to run it on AWS or anything. This is just us sharing what our hardware is working. We see is working fine for us right now. But please definitely try different hardware, different cloud providers, and different configurations. That I think that's going to give us the most information as possible.
And do we need to think about some geolocation? Will it affect? No?
No, I don't expect to. Like we're talking about proving times in the order of minutes. So 100 milliseconds of latency because of geolocation is not going to make a difference.
Okay, thank you.
Sure. Bilal, I think you're next.
Yeah, hey guys, so just a quick question. So right now I can see that the L1 is mentioned as an Ethereum fork. Will it always be the Ethereum fork for the L1, or will you transition to standard Ethereum?
I think that during the scope of the integration, we'll probably stick with an Anvil instance. It may or may not be an L1 fork or just a standalone Anvil. We may want to change that in the future. But most likely we still would stick with Anvil unless we see any sort of stability issues. Eventually, yes, ProverNet will transition to be connected to Sepolia to have something more interesting for testing. But that's not going to happen in the next month or so.
Okay, sounds good. Thank you.
Sure. Cohen?
Yeah, thanks. I'm working on a custom integration, and I'm trying to kind of figure out what the best starting point is. I see like there's multiple different, what do you call them, like projects inside of the GitHub repo, but I'm kind of having a hard time finding where to start, what to kind of take and build as our own.
Got it. I think that sorry, probably the place where you want to start is on the prover agent side. You should see, I can share more pointers to specific source files later, but you will see an entry point for the prover agent that basically connects to the prover node to the queue exposed by the prover node in order to pull jobs from there. I think that's probably one of the points where you want to start integrating, unless you want to use your own queue implementation for handling jobs, in which case you'll need to change the prover node. Again, we can share in which files you need to look into for that. But if not, honestly, I would start by the entry point of the prover agent.
Okay, I'm looking into the queue, like specifically the queue system, so it's a little bit harder. So if I understand it correctly, I should just fork this and build my own. And
okay,
like I'm assuming that at some point it will require updating in terms of if you guys change anything on your side. And that communication faults require quite a bit of maintenance.
Yeah, we'll keep doing updates. I don't expect the shape of the things that we're pushing through the queue to change massively. That should be pretty much the same. We may change the implementation of the queue in the future for something a bit more robust. Right now, it's something that sits within the prover node in memory. Yeah, that's something that may change. That's still the interface between the what we call the proving orchestrator, which is the component within the prover node that actually pushes jobs into the queue, and the queue itself. That interface shouldn't change much. So again, if you make a change in the queue itself, I don't expect a lot of pains in terms of maintenance.
Okay, perfect. If I have any questions, I'll follow up.
Yeah, one thing to note for people over the next, probably starting on Monday, we will start to kind of put through slightly larger blocks. So at the moment, we're just doing small four transaction blocks. We will kind of vary that ahead of the contest next week to test larger block sizes as well.
Okay. Jim?
Just interested to know if you guys, via the software, are sort of inferring anything around the specs of, the hardware, the CPUs, whatever that provers are using. Are you collecting anything like that? Is it a discussion we'll have at the, after the competition? What's your expectations around, talking about the hardware that's being used, that kind of discussion? I imagine a lot of people want to. Some people maybe want to keep things to themselves at the moment.
Honestly, yeah, we would love to get as much information as possible from what you guys are running. As you say, James, I would expect people that are a bit reluctant to sharing. I would expect that at the very least after the contest is finished, people are more willing to be open about that information. We may eventually add some sort of telemetry, opt-in telemetry, to report like what kind of hardware, what numbers you're seeing as you're running the prover, so we can get more information of what people are running. Today, the nodes don't have anything like that built into. If we do, you guys will get a heads up. No worries. We'll not start scraping data off you.
Cool. Good to know.
What are we running it against, Paolo and Phil, again? It's 64 gigs of RAM and 16 cores, or have I got that?
No, double that. Go ahead, Phil, sorry.
Our provers are 128 gigs and 32 cores. The 128 gigs really is just for the tube circuit. Most of the circuits don't actually need anything like that much. And hopefully that requirement's going to come down. And as for CPU, we actually don't get above sort of 50%. So it's possible that you could get away with a 16-core machine. But that's just what we're running. We're running M5 8x large instances in EC2, for those familiar.
And to be clear, this is for the prover agent. Like the prover node definitely doesn't need this power because the node is not running any proofs itself.
That's super interesting already, guys, because I'm watching the agent, and I'm already seeing interesting behavior. It's interesting, Phil, your observations there on the CPU, because I'm seeing, many more cores spike to 100%, but for very, very short periods of time, maybe tens of milliseconds. So it's interesting to hear your experience already. So I'm really keen to see what this looks like once you start putting bigger blocks in.
Yeah, those stats I'm looking at are coming out of Grafana, so they will be averaged, and I'm sure we're missing spikes and that sort of thing.
Yeah. And to be clear, bigger blocks should not put a bigger pressure on prover agents, should put a bigger pressure on prover nodes. Like the proving agent, by default, takes one job at a time out of the queue, processes it, and goes back. So for the proving agent perspective, like it's the same whether it's 1,000 transactions or one transaction in a block. It just pulls a job that completes it and pushes it back to the node. It's the node that will have a harder time processing through the transactions and finding out the jobs to the agents.
Is that a CPU bound task, Santi?
Yeah.
Okay.
You may also need more prover agents to kind of do things quickly. Like if the roll-up scales, you can parallelize the prover agents. So depending on that side of things, that's where the architecture gets a bit more interesting. It's kind of how you parallelize out your jobs over your prover agents.
When you say that, could I just clone my prover agent right now and run 10 of them? Would that be a useful thing to do right now, or is that pointless?
I think that 10. Sorry, go ahead, Phil.
No. 10 would be overkill. If you did, I think it will scale up to about 4. That's where you'd see the improvement.
Okay.
Because we're running 4 transactions per block.
Got it. Yeah.
Okay.
Just as a heuristic though, like for mainnet, if we're not going to do this in the actual contest, but like if blocks are kind of 1,000 plus transactions, then you can see how you would want mass parallelization there for short periods of time. For the contest, I think we'll probably tap out at 16 or 32 transactions as a maximum. You will need some parallelization.
In terms of parallelization, you can either increase this environment variable prover agent concurrency that you can increase within each prover agent, or you can just spin up more instances. Also, I would just suggest spinning up more instances because just with concurrency of 1, it's already pretty memory hungry. Okay, I think Dennis, you're next.
Hey folks, so quick question. I just got started with this project. So I just want to confirm something, that for the contest that we just need to be running a prover node and a prover agent. Is that right?
One prover node and possibly multiple proving agents so that you don't lag behind.
Okay, got it. Any storage specs for the agent or node?
Yeah, those are the numbers that Phil just shared. We're seeing we're having good performance with 128 gigs of RAM and 32 cores for the prover agents.
Mm-hmm.
And the node, I think it's running well with 2 CPUs and 4 gigs of RAM.
Oh, okay, cool. But anything about the storage, like SSD or the volumes? I mean.
Yeah, I don't think that we have anything anything interesting in terms of storage. Like, Phil, can you think of anything other than, I don't know, loading the CRS, and that would be pretty much it, right?
I mean, I don't think having an SSD. I think the storage performance would particularly impact this contest and the sort of the stuff we're doing within the domain, the context of this contest. I mean, eventually, yes, I think nodes will need to run on SSDs, but I don't think you need to worry about that for the time being.
All right. Thanks, folks.
Yeah, and storage is going to be much more important for the node than for the agent, because the node is the actual node for the where it needs to keep all the state, whereas the agent is a lot more dumb and just receives everything already processed by the node.
All right, understood.
Cohen?
Yeah, I actually had a question that was kind of already answered about how many transactions do you expect per block, that have to be approved. That was kind of already answered, but then the question came up was how long does it roughly take now to approve a transaction? And I guess that can differ depending on the complexity of the transaction.
Yeah, I think that we're keeping transaction complexity pretty stable. Like, the plan is not to increase it too much. If we do, we'll probably we'll give you a heads up. If you remind me, I think that we're in about 1 minute or 2 minutes.
Sorry, what's that for?
Time for proving a single transaction. Like, that would be tube plus base, basically, and public.
Oh, that's. I mean, the tube's about 5 minutes. The base is about 3 minutes, I think. Yeah, it's about 8 minutes per transaction. Then that's obviously. Then you've got the kernels. So we did these transactions have a single public function, I think. So we do an application logic and a tail kernel. So that does add another couple of minutes.
Okay.
So if I'm correct, the timeout is about 20 minutes now. So if we're already doing 5 transactions per block, doesn't that mean that if you're only running one prover agent, that will kind of already time out? And if you're not, if you're only running one of them?
Yeah. To be clear, a timeout is not enforced by the protocol. Like, your transaction will be accepted anyway. It's just what we'll be counting for purposes of the contest. But yeah.
Okay, thank you.
Just a bit of rationale on that. Like, on eventual kind of like public testnets and mainnets, the timeout will be enforced by the protocol, but not for this contest. It's kind of our finality liveness guarantees. So yeah, if something's not proven within a certain time, then we have to assume that something's gone wrong, and the block would be rolled back. So long term, it will be also actually enforced. But yeah, as Paula said, we'll only be enforcing it for the contest. You can still test and submit things after the timeout on the ProverNet.
Okay. Do we have any other questions? These are great, by the way. Thanks. thanks so much for bringing all of this up.
Awesome. Should we move on to a demo?
Let's. Yeah, the plan it's going to be a very, very short one, just about how to set up everything on an instance for running an Aztec prover node and a proving agent, and show you how it's look like. It's not going to be anything fancy, just looking at the terminal, maybe 2 terminals, and watching logs. That's about as far as it's going to go. Let me switch screens for a second. Okay. So let me bring everything up. Okay. Yeah, perfect. So step 1, in case, to be clear, like all of the steps that we're running through now are linked to in the Pro integration guide. Still, if you guys have any questions, please feel free to ask. Step 1, oops, sorry. Step 1 is basically to install Aztec, which is just a one-liner that's going to pull from install.aztec network. It's going to install a couple of scripts, so you can actually have an Aztec on your command line. This basically installs a CLI that lets you run some operations on the Aztec network, but most importantly, it exposes a start command that will let you start the different components, like a node, a prover node, a prover agent, etc. Something very, very important for the purposes, oops, sorry about that. Yes, I'm copy pasting from HackMP. For the purposes of this integration, we're working with a tag named ProverNet. Make sure you use that tag, otherwise you will get very, very annoying errors because interfaces will not line up. And this will make sure that you're running on the correct version. Before this call, I had set up a couple of environment files, in particular one for the node, which has all the environment variables that we discussed on the integration guide. Yes, you can see my private key there. No, we don't have any money in it. And basically configuration for connecting to the remote network. The most important ones are the Ethereum host that points to the main network that we're using, and the provider node URL that points to the Aztec node that we are running, that your prover node will use for pulling down transaction proofs. Remember that in the context of the Aztec network, individual proofs for each transaction are not submitted to L1, so you need your prover node will need to grab them either from another node or from the B2B layer. For now, they are grabbing it just from another node, and this is going to be the central node, the central sequencer that we're running. And the other important thing is remember to set up the API key to the value that Phil has shared, and your private key that probably needs to be repeated also as prover publisher private key, and the address that corresponds to that will be used as basically your identifier. So let me source this real quick. And just in case, I'm going to ask for some funds. Basically, you want to have oh my god, okay, I ran this just a little while ago to make sure it worked. I got rate limited. We have a faucet that's going to be ETH. It's going to give you ETH, so you can pay for sending the transactions with the proofs. Basically, the prover node, once it has collected all the relevant, once it has assembled the root rollup proof for a given block, is going to send the transaction directly to L1, to the L1 fork, with the proof itself, and that's what we will be monitoring. In order to do that, you need ETH to pay for the gas. That's what this faucet is about. On every run, it's going to be giving you 1 ETH. I think you can call it once a day. 1 ETH will be plenty for everything you need. So no worries about that. And okay, with all that, I think we can actually properly start a node. Basically, we're going to start a prover node with a local archiver. Archiver is the component that basically downloads all data from L1, keeps a local copy of what's happening. You have the option of running the archiver in a separate process. For the purposes of the prover node, we suggest to run it within the same process. Yeah, so this is going to connect to the chain running on AWS. and hopefully download all information, catch up, and start figuring out what nodes need to be proven. And which blocks need to be proven. Remember, on Aztec, we always have the concept of the latest submitted block and the latest proven block. The prover node will be constantly checking that difference, grabbing all the nodes remaining to be proven, and start creating proofs for them. So with the prover node running, let's see. Yes, we have the prover node running. Perfect. Remember, the Aztec command, what's doing behind the scenes is basically starting Docker containers for you. So what I'm going to do is just source the environment variables for the agent, which are not particularly interesting. But the important thing here is connecting the agent to the prover node. That's the main thing that you need to look into. Like the agent is going to be constantly polling the node for new jobs and basically consuming those jobs from the queue. So make sure that this URL points to wherever you have started your prover node. In this case, I'm starting everything on the same machine, actually on the same Docker network, hence host Docker internal. But if you're running them on different machines, which if you're running multiple prover agents, you probably should, this should be pointing to wherever you're running your Aztec node. And well, let me just start the prover agent. Yeah, it has already started pulling jobs, it seems. Actually, yeah, there it goes. So yeah, this is basically it. The prover node will now wait until the prover agent has managed to generate all the proofs for all the transactions in the block and assembled all the hierarchy of circuits until it gets to the root rollup. And once it gets the proof for the root rollup, the prover node is going to be the responsible one for submitting it to L1. And that's basically it. There's not much more to it other than keeping an eye on the logs and what are metrics that you want to follow. I'll keep sharing, but we can. I think we can resume the session now. Yeah.
Just as a basic kind of gotcha, so you may be waiting like an hour in this case with one prover agent to prove a whole block based on some Phil's numbers.
It's probably going to be over half an hour at least.
Yeah, but definitely don't expect for me to be talking for half an hour and filling the time.
So yeah, but this is awesome. Thanks, Pala.
Sure.
All right, should we get back to the slides? And any other questions?
I mean, these are the questions that we lifted from the channel. Recommended hardware configuration, I think we already went through it. Prometheus metrics, we discussed the OpenTelemetry collector. As for the list of the metrics actually being generated, I think we can collect them and share them in the documentation. Note that they are subject to change. Like, don't expect the metrics to be a stable interface. We won't be changing them like crazy, but that's not something that we have stabilized yet. As for generating a dashboard, please definitely play with those metrics for generating a dashboard of your own. On the repo, you can also see the Grafana definition for the dashboard that we are using internally, and we'll also try to generate a public dashboard with public information for everyone to see. We'll probably be sharing that next week. In terms of bottlenecks, sorry, please stop me if you have any additional questions on top of this. Okay. In terms of competition, what's the bottleneck for improving stats? Again, focus on reliability and on being able to prove everything within those 20 minutes, which means spinning up as many prover agents as you need. In terms of support for JSON logs, that's right around the corner.
Cool. Should we carve out some time for people thinking about custom integrations? If anyone wants to kind of share any issues they've run into. We do have 2 tracks going on here. One is kind of just running the software as is, as Pala demoed. But those who are building kind of more blockchain-based prover networks, maybe doing kind of more in-depth integrations. So we can have a specific session to discuss issues or the queue or the interface between the node and the agent, if any questions come up. If you have any, please just raise your hand and join the queue.
Yeah, maybe a good time to mention we had 23 entries, so there's 23 parties working on this, and 11 of them will be doing custom integrations. But only a couple signaled in the poll that they started working on a custom integration, Joe. So if we don't get any questions on the custom integration side of things, maybe some of the guys not on.
Do we want to stop the recording if there are no other questions, so people can ask away without fear of getting recorded?
Sounds great.